Kia ora koutou. This question is a request for Daniel, and it's out of the booklet that I gave out in class about 10 days ago, the one that I did work solutions for the first half. So this is in the second half, and this is a question that uses implicit differentiation, and you do have to keep your wits about you to get all the way through it. So we've got a curve, which is the natural log of x plus y, and that's equal to x minus 2y. We have to show that dy by dx equals this. And I think the thing that freaks you out at first is that you see this combined x plus y. But let's just think about what we're doing when we differentiate with respect to x. What we want to do is to say, well, we know that the two sides of the the two sides of the equation are equal. So that means that when I differentiate both sides with respect to x, the derivatives are still going to be equal. So let's look first of all at the right-hand side, because that's just fine. When we differentiate x with respect to x, we get 1. And when we differentiate 2y with respect to x, we're going to get minus 2 times dy by dx. Right? So we differentiate this with respect to y, and then we use the chain rule to differentiate it with respect to x. I'm assuming if you're watching this since we are in about September that you're good with the basics of implicit. Now we're going to do the same thing on the left-hand side. We're going to differentiate the natural log of a thing with respect to x. So when we differentiate the natural log of anything, it's 1 over the thing, 1 over x plus y. And now we have to differentiate the inside function with respect to x. So x will differentiate to 1, and then y, well, when we differentiate y with respect to x, we get dy by dx. And that's all there is to it. And now what we have to do is just collect up the terms with dy by dx in them. So doing that quickly, we get 1 over x plus y plus 1 over x plus y times dy by dx is equal to 1 minus 2 times dy by dx. So I'm going to bring this over, add this to both sides, and subtract this from both sides. That will give me dy by dx into 2 plus 1 over x plus y is equal to 1 minus 1 over x plus y. Let's get a common denominator. You can see, hopefully, that we're just about there on what looked like a really difficult question, but actually is not too bad. Okay, and now we can cross multiply. We get dy by dx is equal to x plus y minus 1 over x plus y times x plus y over 2 into x plus y plus 1. And I think that's the form we need to show. Yep, that's exactly what we needed to show. X plus y minus 1 over 2 times x plus y plus 1 as required. Okay, so not too bad, just go slowly and think about what it means to differentiate with respect to x. So that's 4 marks. For the second part, we have to find the coordinates of the point on the curve where the tangent is parallel to the x-axis. So for something to be parallel to the x-axis, we need to find when is dy by dx equal to 0. So dy by dx equals 0 means that x plus y minus 1 has to equal 0. Right, so x plus y equals 1. Let's take this condition and put it back into the original curve. Well, the original curve was that the log of x plus y is equal to x minus 2y. That gives me the log of 1 is equal to x minus 2 times 1 minus x. Just rearranging this to get y is equal to 1 minus x. That gives me 0 is equal to x plus 2x, so 3x minus 2. I'm just checking that I haven't made a mistake here. Let's see. Yep, that looks good. Okay, so I got something different when I did this before. Hang on. I know one of you will tell me if I've made a mistake here, but I think it's x minus 2y. Yep. Okay, so 3x minus 2. 2 is equal to 3x, x is equal to 2/3, and y is equal to 1/3. So the point is 2/3, 1/3 is the answer. What someone might want to do is very quickly just sketch that in GeoGebra and see if that all makes sense. That would be useful, but I haven't got GeoGebra open on my laptop at the moment. Daniel, thanks for sending in that question. Guys, please keep sending in anything little like this that you're finding from all the revision sheets. I'll do some more later on.